Today we're going to begin our study of polynomials, but we're going to look at quadratics first, which are a type of polynomial. They're the type of polynomial where they can be written as ax squared plus bx plus c. So the primary characteristic is that the degree is second power. The things that will be important to us in our study of quadratics today will be where is the vertex and where are the x-intercepts. The vertex is either in the valley, right? It's the minimum, or if the parabola, the shape of a quadratic, is going this way, then it would be the maximum point. That's the vertex. And we have lots of ways of finding that. And then the x-intercepts, which, let's say that's the x-axis. It could be that our quadratic has no x-intercepts, that it has one x-intercept, or that it has two x-intercepts. Okay, so it's possible that the answer to x-intercepts is none, one, or two. None, one, or two. And we're going to have several techniques for finding x-intercepts as well. All right, so let's take x squared minus 5 from our study of transformations. We know that this one looks like this. So based on a sketch, I could determine that the vertex is at 0, -5. To find the x-intercepts, I set y equal to 0. So 0 is equal to x squared minus 5. Add 5 to both sides. Square root. So my x-intercepts are positive or negative square root of 5. So I should write that as positive or negative square root of 5, comma 0. Those are my x-intercepts. Those would be the coordinates for those 2 points. G of x, again, using good transformation thoughts, we know that this parabola moved right 3 and down 4. So it's somewhere here. So its vertex is at 3, -4. And its x-intercepts I could either FOIL this out, collect like terms, factor it, but because there's only an x here, I'm going to add 4 to both sides. I'm going to try and make my life easy. Take the square root of both sides, so plus or minus 2 is equal to x minus 3. Add 3 to both sides, and I will get that x is equal to 2 plus 3, 5, or -2 plus 3, 1. So my x-intercepts are at 5, 0, and 1, 0. This quadratic isn't being as informative as the prior two, so I may need to develop some new techniques. My vertex, since it's not in transformation form, I can use, and hopefully you'll remember this, that the vertex is at the opposite of b over 2a, and then you plug that in to find the y-coordinate of the vertex. So b is 6, so the opposite of b is -6. A is 1, so 2a, 2 times 1. So the x-coordinate of the vertex is -3. And then if I plug that in for x, right, if I know x, I can find y. -3 squared plus 6 times -3 minus 27, so 9 minus 18 minus 27, so that would be -9 minus 27, -36. So my vertex is at -3. negative 36. My x-intercepts will occur where y is 0. Oops, plus 6x. Okay, I think this will factor x and x, 9 and 3, with a positive 9 and a negative 3. So x plus 9 equals 0, x minus 3 equals 0. So at negative 9, 0, and positive 3, 0. So if I were to sketch this, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, negative 9, 0, negative 3, let's just call that negative 36. It's just a sketch, so there we go. There's my parabola. Again, may have some trouble with vertex since it's not in transformation form. So I'm going to do the vertex is at opposite b over 2a, and then I'm going to plug that in. So negative 3 over 2 times 2, 4, negative 3/4. So I'm going to get 2 times negative 3/4 squared plus 3 times negative 3/4 plus 5. This would be 9/16. So 9/8, right, if I multiply it by 2, 9/16. This would be minus 9/4 plus 5. Well, a little common denominator action here. 9/8 minus 18/8 plus 40/8. So negative 9 plus 40 would be 31/8. Again, I'm working quickly, so if my math is bad, forgive me. My x-intercepts are going to occur where y is 0. 2x squared plus 3x plus 5. I don't think that's going to factor. I think I set it up not to factor. So I can solve this by using the quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So this 9 minus 40 is a negative number, so my x-intercepts would be imaginary, but x-intercepts have to be real things on the x-axis. So I have no x-intercepts. So obviously this thing looks like it's at negative 3/4 and it goes up like this. So it doesn't have any x-intercepts. Okay, again, vertex I'm going to have to do opposite b over 2a. So negative 6 over 2 times negative 3, so negative 6, 1. That's nice. Negative 3 times 1 squared plus 6 times 1 plus 1. So that's negative 3 plus 6 plus 1. So that's 3 and 1, 4. There's my vertex. My x-intercepts, 0 equals negative 3x squared plus 6x plus 1. I'm going to do quadratic formula again. So my x-intercepts, x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So I get negative 6 plus or minus the square root of 48 over negative 6. Negative 6 plus or minus 4 root 3, right? The square root of 48 would be 16 times 3, which would be 4 root 3, over negative 6, which I could factor a 2. Maybe I should factor a 2 out of the numerator, so I'm going to get negative 3 plus or minus 2 root 3. And that 2 is going to cancel with my negative 6 and make negative 3. So my x-intercepts, let's see, how do I want to write these? Probably as, let me factor the negative out of here and run it across the top. So I'm going to get, you'd probably more likely see it as 3 plus or minus 2 root 3 over 3, comma 0. Okay, different skill. What if I tell you where the vertex is and a point that the parabola goes through and ask you to find the equation? You've done this with line, you know, given the slope and a point, find the equation of a line. Well, how does it work for parabola? I'm going to tell you that the equation you want to go toward is the one that actually has the vertex embedded in it. So we use x minus h squared plus k and put a constant here in case there's something multiplied by it to make it upside down or wider or narrower. Okay, so the vertex is at hk. So this is h and this is k. So we're going to get y equals a times x minus 3 squared plus negative 2 or minus 2. And just like when you know the slope and you don't know the y-intercept, when you know the vertex, but you don't know whether it's right side up, upside down, tall, short, however, we're going to use this point, we're going to plug this in as x and y temporarily to find a. So 7 equals a, oops, pardon me. Oh, 5 minus 3 squared minus 2. Okay, so 7 equals 2 squared, 4a minus 2. So 9 equals 4a. So a equals 9/4. So I can come back and say this should have been 9/4. There's my equation of the parabola.